It's a great pleasure to be back to Brasilia, and I wish to thank the organizers and all those who helped them. When we move from the abstract realm of mathematics to the concrete realm, the place where we are most likely to encounter true contradictions is arguably time and change. And I think you all agree that the idea that things change and that time passes is deeply rooted in our emotional lives and cognitive lives and even existential lives. And yet when we try to understand in clear conceptual details what these notions amount to, contradictions keep cropping up. And in fact, this has been so since the dawn of Western thought, when in ancient Greece, the philosophers tried to understand what change and motion and passage entailed. They realized that it was very hard to get rid of contradictions, and this led to the surprising circumstance that two radical schools emerged. On the one side, the school associated with the Eleatic school, Parmenides and Zeno, who denied the reality of change and passage. And on the other hand, the school associated with Heraclitus, who actually accepted that perhaps reality might be contradictory after all. And now, I think, I won't argue for this here, but I think that if you deny the reality of passage, you must admit that we are deluded about it. And this is an inconsistent view, I think. So, this would mean that reality is either inconsistent or inconsistent. The only view remaining is the absurd view that we are not only deluded about the nature of reality, but also about the nature of our own perception of reality. So, Graham Priest has been the one who has done the most in contemporary times to make a case for the existence of true contradictions. And understandably, all of us, I think, would do better if we could find a way to, a middle way that avoids contradiction and also avoids the absurd view that we are deluded about our own perception of time and change. And indeed, in the 20th century, what is now the received view, the Russellian view, has been trying to do so. I will briefly present the Russellian account of change that occurs the arithmetization of time, since it heavily relies on the arithmetization of calculus by mathematicians in the late 19th century. And I will then present Priest's criticism of Russell's account, with which I totally agree. And you see, the argument in most of my discussion here comes from a book that Priest published in 1987 called In Contradiction. And the general structure as far as time and change is concerned in Priest's arguments has been abducted, in the sense that since the only or the best theory that we have that avoids both contradictions and the denial of change can be proved to be wrong or unsatisfactory, well then we must at least countenance the possibility that contradictions are real. I will then present his own view of motion and change, which is the part that I wish to criticize. And I will then conclude with where I wish to locate the problem. I will argue that if Priest's view of change is correct, then also the orthodox view is correct. But since I don't think that the orthodox view is correct, I agree with Priest on that, well then I think that they either both fail or succeed. Okay, so brief introduction to the Russellian view. is frozen apart. Should I point it that way? Okay. So this is it going to be possible to squeeze it a bit more so that we can see everything? Because it's not really important, but excellent. Okay, so you probably all know this argument from Zeno, the Arab argument, and this is how Priest reconstructs it. So consider a point object in uniform motion from x to y, and let's say the tip of an arrow, and consider an instant of its motion, t0, rho. Okay. At t0, the arrow advances not on its journey to y, and if it did make some headway, then it would take time. And therefore, it would not be an instant, the t0 time. But a temporal interval is made up of such points. And it would therefore seem that since no progress is made in any basic part of the interval, then no progress can be made on the whole. Right? This is a familiar arrow argument. Now, the standard understanding, this is what we learn in physics classes and in philosophy, is kind of a philosophical gossip, is that calculus finally solved this problem. And the idea is quite familiar, is this. Of course, each instant is durationless, but nonetheless the object may have an instantaneous velocity that it's familiar to describe that as the derivative of the kinematic function. And when it was first discovered by Leibniz and Newton, the idea was that these little things here were actually magnitudes of a very strange kind. They were smaller than any other magnitudes, and yet they were not zero. And this was the problem that we had for centuries before we made it to a coherent account. And this is how John Berkeley ridiculed what this view. And he said, what are these fractions? Fractions are derivatives in Newton's terminology. The velocities of evanescent increments. And what are these same evanescent increments? They're neither finite quantities, nor quantities infinitely small, nor yet nothing. But we don't call them the ghosts of departed quantities. And in fact, everybody agreed that there was something wrong with these notions. And here comes the villains of my story. In the late 19th century, some brilliant mathematicians finally freed calculus from the inconsistencies by effectively eliminating infinitesimals, these evanescent increments. And the idea, also pretty familiar, is to introduce the notion of limit. And the idea here is to treat this as a quantifier. This is the familiar epsilon understanding of the limit. Now, what is relevant for our concern here is that, well, this is clearly consistent, we know it is consistent. The problem it has for us is that this understanding, this condition that numbers must satisfy, makes of instantaneous velocity a relational property or a neighborhood property rather than an intrinsic property. And as we shall see, this is a major problem for the orthodox view. So, let me get that because I can't really see much. So here is how Russell expressed the final solution to the problem. Weierstrass, by strictly banishing all infinitesimals, has thus shown that we live in an unchanging world, and that Zeno's arrow, at every moment of its flight, is truly at rest. And notice that Russell does not want to claim that things do not change, right? He just wants to say that they do not change by changing, if you want. There is no state of motion, according to this view, or state of change. Now, let me say since now that whatever we said about the arrow argument does not involve necessarily the case of motion. That's a particular case of change, but it also applies equally well to the case of passage. As you can see, this is a representation of the passage of time, and if the argument goes through in the case of motion, it clearly goes through in the case of passage too. Now, here go the criticism, with which, as I said, I fully agree. So the first problem that we're going to discuss, I call the problem of incremental accretion. That one can prove a small mathematical theorem of two is one thing, but it does not ease the discomfort that one finds, or at least that I find, and I find too, when one tries to understand what is going on physically, when one tries to understand how the arrow actually achieves its motion. At any point in its motion, it advances not at all. Yet in some apparently magical way, in a collection of these advances, now a sum of nothings, even infinitely many nothings, is nothing. So how does it do it? Indeed, how does it do it? Now, nowadays, these worries are sometimes met with contempt. People say, well, don't you know calculus? Don't you understand? And here is one example. These days, by leftover, these days no one worth his salt thinks instants add up to periods this way. There are instants, periods are instants with distance relation between them. The relations, not the relata, account for periods extensions. That is why, in the paradox, without putting distance relations between the points, we don't get an extension. You see, this is the idea of how we get extensions. You just add them up, and we know that the calculus actually works. Newton knew it well, and in fact it does work. And the thing is that according to the systematization that was given in the late 19th century, this should not be understood as a sum of things. What really does the job are relations. Now, I anticipate the problem with this view is that if it is the relations that are doing the job, then it is not clear how you could reach any extension. Now, this might be fine for space, because space is already there, spread out somehow. But with time, this, as we shall see, is a deep problem. And this is the way in which William James put it. A God, as the Orthodox believe, created the space continuum with its infinite parts already standing in it by an instantaneous fiat. Past time now stands in infinite perspective and may conceivably have been created so, as Kant imagined, for our introspection only, and all at once. Omega was created by a single decree in a single act of definition in Professor Cantor's mind. But he who so actually transverses a continuum, like the arrow, like Achilles and the tortoise, or time, for that matter, can do so by no processes continuous in the mathematical sense, be it short or long. Each point must be occupied in its due order of succession. And at each time you add something, you're adding zero. So how does it do it? And let me get to the second problem that I want to discuss. I call it the non-intrinsicality of motion. It follows from the definition that there is no such thing as an intrinsic state of motion. If one had a body in motion and took, as it were, a logical picture of it at an instant, the picture obtained would be no different from one of the same body at the same place, but at rest. Of course, an object in motion can have an instantaneous non-zero velocity, but it would be wrong to think that this differentiates it intrinsically from a static body. Now, a number of authors in more recent time argued in similar ways for the claim that the fact that intrinsic velocity is not intrinsic really, or that instantaneous velocity is not an intrinsic feature of objects is a problem. And one famous argument called the ball argument goes like this. Suppose that you have two identical balls, one is standing still, the other is moving. By the way, I will always talk as if there existed an absolute motion, but really it's just for a matter of simplicity. Nothing hinges upon this. We can rephrase everything in relational terms. The idea here is that, okay, suppose that this is a ball moving, right? And this is a ball standing still. Now, if you take a picture of the universe right now, these two goals are absolutely indistinguishable. The whole universe is indistinguishable if it had this goal and that goal in the other. Now the question is, why does it move? Right? How does it know that it should move? Okay, let me tell you another symptom of this disease. Now, this is an asteroid impacting on Earth, and we all know that it is going to create a crater, and it is reasonable to ask why the diameter of the impact crater is exactly what it is. And the answer, the standard answer, is because it has a certain instantaneous velocity at the time of the impact, right? But if the universe is indistinguishable, if this is moving or it is not moving, because velocity is not an intrinsic feature of objects, then how does it know that it should create a crater of that size? Another way to put it is to ask, why do asteroids always fall into craters? Isn't that a miracle of some kind? Let me get to the third problem. Last one is the direction of time. What accounts for the anisotropy of time? This again has been a thorny problem, particularly for those who have denied the reality of the flow of time. They've had to locate the anisotropy of time, not in time itself, but in processes in time. A tall order, since apparently the causal laws are time symmetric. Now, I certainly agree that this is a tall order, but I think that there is a deeper problem with this idea, and we shall discuss this last. Okay, now to Priest's own account of motion. He calls it the Hegelian account of motion because it is inspired by the work of Hegel. Yes. Okay, so preliminaries. Consider a body in motion, say a point particle. At a certain instant of time, t, it occupies a certain point of space, x, and since it is there, it is not anywhere else. But now consider a time very, very close to t prime. Let us suppose that over such a small interval of time as that between t and t prime, it is impossible to locate a body. Thus, the body is equally at the place it occupies at t prime, x prime. Hence, at this instant, the body is both at x and at x prime, and equally not at either. Now, I've emphasized this since, because eventually I anticipate, I want to criticize the view on the ground that the position, the inconsistent locations that the object has at the same time are independent from one another. And the fact that it is not at x is a consequence of the fact that it is also somewhere else. And the other thing that I want to point out is that the idea that it is impossible to locate the object should not be understood in the epistemic sense. We are talking about some kind of ontological impossibility. It is reality itself that does not fix the location of the object. Okay, so this is the spread hypothesis. A body cannot be localized to a point it is occupying at an instant of time, but only to those points it occupies in a small neighborhood of that time. A neighborhood that Priest calls a spread. Okay, so this is how the Russellian view looks like. So that the motion of a body be represented by the familiar equation, then the evaluation which corresponds to the motion according to the Russellian account is given by these two conditions. Now, this condition tells us where the body is, and this condition tells us where the body is not. And you see, in a classical understanding, you wouldn't need this because of the very fact that the body is localized at a certain point R already entails that it is not localized elsewhere. But since we want to compare this with a view according to which contradictions might be true, we need that too. Oops. Yes. Okay, and notice since now that in the case of the passage of time itself, the function that we have here is simply identity. Okay, so the same view applies to the passage of time. The idea that there is a spread applies to bodies in motion, and also to the present time, which would be spread somewhat. And okay, so this is how the account is supposed to solve the first problem that we have encountered. The Hegelian account of motion may be taken to locate the fault in the arrow argument, but at a point different from that upon which Russell lies. For according to Zeno's argument, at a particular point in time, the object occupies only a single point in space, whence it follows that it advances not on its journey during that instant, i.e. that the measure of the set of points occupied at that instant is zero. Given the spread hypothesis, however, it is not true that the moving body occupies only a single point. At an instant t, it occupies all the points in the spread, which is in general not a singleton. Indeed, provided the function of motion at is continuous, sigma t is an interval and therefore has non-zero measure. Thus, advance is made during a single instant, and hence during the aggregate of instants. You see, this is the idea. You deny the assumption that the body is located at one particular position, and this explains how it makes an advance. Now, this is what I find satisfactory with this view. The quickest way I know to expose the difficulty is to pose the same argument to the spread hypothesis itself, the same arrow argument. And this is how it goes. At each moment during its journey, an object occupies inconsistently a region of space the same size as its spread, sigma t. This is the spread hypothesis, the Hegelian understanding. During each instant t, the spread sigma t of location occupied by the object advances not at all. Then how does it manage to advance over a finite interval of time, given that this is constituted by nothing but a sequence of such spreads? Now, this is another way in which we may press this point. Priest makes the interesting suggestion that the extension of the spread might be linked to quantum indeterminacies. Perhaps the measure of sigma t just is the uncertainty of the location of the object t. Perhaps quantum mechanical indeterminacies are fundamentally the result of inconsistencies in motion, and in particular in the spread postulated by the spread hypothesis. This suggestion at least allows us to give physical significance to the spread. Now, this is how the problem is. You don't need to know the details of this. This is just an equation giving the function. The function psi gives the complete state of an object. And in this case, it gives us how this changes as time goes by. Now, over the finite interval of time, the state of the particle changes from one function to another function. And but at each time during its journey, the state of the particle changes not at all. And so the question is, how is it that in a sum of these changing not at all, the function makes it? Or why does it change? Right? Suppose that these are the two functions. Each one of them, you see, occupies the same spread. And the problem we had was to explain how things move, how things change. So if a classically localized body cannot move because at each instant it does not move, then how is it that the spread of location could move, given that it is occupying a space equal its size, just like an arrow? Okay, this is... now I'm going to give counter-arguments to each of Priest's explication of how the account is supposed to work, but in fact I think I only have one argument, but I'll tell you why later. Now, to the problem of non-intrinsicality. This is obviously no problem for the Hegelian account. For it, there is an intrinsic state of motion, a certain inconsistent state. The difference between a body genuinely in motion and one changing place but at rest, each instant is exactly that between a Hegelian state description and the corresponding Russellian one. I think it is pretty clear that Priest is right, that according to the Hegelian account, the state is an intrinsic state as it should be. The point, my argument is that it is not the right kind of intrinsic state. And this is why. So the locations that the ball may inconsistently occupy at any time are totally unrelated to the locations it may occupy at any other time. This is the problem. The nexuses in both the Hegelian and the Russellian account are provided solely by the kinematic function, which features essentially in the Hegelian account too. Why should the instantiation of inconsistent states of affairs as to the location of the ball at the time force it or induce it or dispose it to be elsewhere? Sometimes people speak of the ecstatic nature of time. I think Hegel says that time is unruhe, wants to move somehow. There is something that forces it to move. And this is what we want. This is what we want from the state of motion. It must explain why things change. And now I don't see how contradictions in themselves should make things in motion. I understand why we should want contradictions, because indeed it is hard to understand how motion could not be contradictory. But I don't think that contradictions explain at all why things move. Why should contradictory states of affairs be more dynamic than non-contradictory states of affairs? And now you might think that this dynamical vis of contradiction is that reality wants to avoid contradiction, but this cannot be the explanation, you see, because the only way to avoid contradictions in motion would be to stop, like Aristotle thought that objects should do. And we know that this is not what happens. Contradictions are constantly renewed as things move, if Priest is right. Now the direction of time. The intrinsic nature of the direction of change at t corresponds to a certain asymmetry in the state at t. But which asymmetry is a question that might be answered in several ways. One that is not ad hoc is as follows. Theta t, the spread of the present time, will not necessarily be distributed symmetrically about t. In fact, there are reasons to suppose that t is the leading edge of sigma t, so that the interval is skewed all to the past at t, at least normally. And I won't discuss the reason Priest has rather convincing for thinking that the spread should be asymmetric, but I want to concentrate on a problem that I see with it, that I don't think that any asymmetry will do, and this kind of asymmetry in particular will not do. And this I will dedicate the last section of the talk to explain why I think it is. What accounts for the anisotropy of time? This again has been a thorny problem, particularly for those who have denied the reality of the flow of time. They've had to locate the anisotropy of time not in time, but in processes in time, a tall order, remember. And again, the solution to the problem of the present approach is obvious. Since the identity function is monotonically increasing, Vt is always the upper bound of the spread of Q at t. Thus, the direction of the flow of time is perpetually from past to future, which seems just about right. I want to take issue with this idea. I think that it is, strictly speaking, false that the identity function is monotonically increasing if we understand increasing in the relevant sense. So here goes the last section of my talk. Frozen in time again. Okay, so I want to analyze the kind of direction that asymmetries or asymmetric relations can provide us with. And to do so, I would start by explaining the difference between a mere betweenness order and senses of relations. So the points on a line have an intrinsic order. Here order just means that is a sense of order in which ABC is the same order as CPA, right? The betweenness relation are exactly the same. But think of points in a line, right, like these. They have a certain order, a between relation. It doesn't matter which way you go, but B will always be in between. But there is no sense, right? It doesn't make any sense to ask whether the line is going that way or this way. Now, the sense is exactly what we need, and I think is what Priest is hinting at when he says that the asymmetry would solve the problem. Now, this is actually a standard view, again, due to Bertrand Russell, of how sense is created out of asymmetry. It is characteristic of a relation of two terms that it proceeds, so to speak, from one to the other. This is what may be called the sense of the relation. It is a sort of order and senses. In all cases where a relation RB does not imply BRI, when it is antisymmetric, there is another relation related to I, which must hold between B and A. That is, there is a relation R star such as ARB implies BAI. And further, BR star A implies ARB. This is the converse relation. The relation of R to I is difference of sense. This relation is 1-1, symmetrical and intransitive. Its existence is a source of senses, of the distinction of science, and indeed of the great part of mathematics. So relations, asymmetric relations are supposed to have two senses. The earlier-later relation has a converse that is the later-earlier relation, and so on. Now, there is a deep problem with the association of the senses of relation understood in this sense and the direction of time. Some people, actually most people I know, think that this is the notion of sense is exactly the right notion, and reality simply picks one out, and one of them, right? And I think this is cannot be the case, and I'll tell you why. First, let me mention a few problems with the very notion of a sense. They seem to be indistinguishable. A relation neither exists nor can be observed apart from its converse relation. What is more, the concept of a relation and of its converse is one and the same indivisible mental capacity, and we cannot exercise this capacity without actually thinking of both relations together. Now, we cannot establish by our use of a sign for a binary non-symmetric relation that we mean to pick it out rather than its converse R star. Now, this seems to be strange, but I will tell you why this is so. This is how McBride expresses the difficulty. A non-symmetric relation and its converse are so closely bound together that whatever construction we use to notationally pick one out, we might equally well have used the same construction to notationally pick out the other. For example, we may have used the construction A is before B to mean what we currently mean by B is after A, and vice versa. There are a number of arguments in recent literature that go in this direction. In particular, one, maybe the radical position by Kit Fine, simply denies that there are two different senses at all, two different relations at all, right? So the reason why we think there are two different senses is that the relations, asymmetric relations, have a differential application. That ARB is different from BRA. Now, this is the structure of Kit Fine's argument. We don't need to get into the details of it. The idea is that these three are inconsistent premises. Every non-symmetric relation has a distinct converse. This is the view that we want to deny. Any state that arises from the holding of a relation R is identical to a state that arises from the holding of its converse. If the cat is on the mat, well, then it seems to be the same state of affairs that the mat is under the cat. And uniqueness, no one state arises from the holding of more than a relation. Now, I don't want to buy on these arguments, but I think they indicate there is a great difficulty. I prefer to show you this difficulty at work in our case. Now, well, this is a curiosity, but I think, how much time do I have? 5 minutes. Oops, well then I will skip the curiosity. Now, let me skip this too. This is how you construct signs, but it doesn't matter. Now this is a description of a kind of motion. This is in 2 dimensions, and it's an object subject to gravity and to an horizontal force. It may be me throwing a ball at you, or you throwing a ball at me. Which one? We don't know. Why? Well, because we haven't been told which of these come first. I suppose this is me, this is you, but which one comes first? Now, so there is an ambiguity in this picture. Now, suppose you make this notational change. You substitute the variable for another, t prime that is minus t. Now you get this equation here. And now this is known as a reverse description. We are actually describing the same phenomenon, the same thing. If this is describing me throwing a ball at you, well then this one is describing me throwing a ball at you too. Okay? Now this instead is meant to represent the reverse phenomenon. So if the first one was meant to describe me throwing a ball at you, this one is meant to describe you throwing a ball at me. Now this is a problem. Look at these things here. Can you tell a difference between these two things? You see, the equation is the same, right? They satisfy the same equation. But clearly they are describing the same phenomenon, or at least they are not capable of capturing the distinction between the two. Remember that Russell is telling us that each value of a variable is a constant. And if so, then these are actually describing the same thing, which seems just about wrong. There's something wrong, right? There is an ambiguity there. I think this is the ambiguity in the notion of sense at work. So this is the problem that we have. Now, what I make of it, this applies to a number of issues. Sometimes we are told that entropy, or the increase of entropy, is the solution to time. No, it isn't. I mean, there is no clear sense in which entropy is increasing rather than decreasing. We know that in one direction it does increase, in the other it decreases. But in itself, a simple asymmetry is not going to give us the right kind of notion. Are real numbers increasing or decreasing? They're neither. It doesn't really make sense to ask whether they are increasing. They're not going anywhere. And although they are asymmetric, I mean, there are structural distinctions between negative numbers and positive numbers, so the real line is asymmetric. But you see, asymmetry, once again, is not going to give us what we want. And now to the point. This is how Priest wants to solve the problem of the direction of time, by giving us an asymmetry of that kind. Since the identity function is monotonically increasing, Vt is always the upper bound of the spread of pure t. Thus, the direction of the flow of time is perpetually from past to future. But it isn't. The identity function isn't increasing or decreasing in any sense. It is only increasing if we assume that we are going in this direction here. What we mean when we say that the identity function is increasing is that if this is the direction of increasing numbers, well then these guys here are going to increase too, okay? But this is not enough to give us a direction, or at least not to give us a direction in the relevant sense. Heraclitus once said that the way up is the way down. I have no idea what he meant, but I thought it was a good mantra to have. This is a pyramid, it is asymmetric, but if you ask, is it going up or down? Well, the question doesn't seem to make much sense. And so here are my conclusions. So I have argued that the Hegelian account of change in Patchett has the very same difficulties that it was devised to solve. So the abductive force of the argument is diminished. These were the problem of the incremental accretion, the problem of non-intrinsicality, and the problem of direction. This doesn't show that contradictory states of affairs are not true of reality. In fact, I think that there are reasons to think that they are. The only alternative is just to deny that the reality of passage, and this is nearly contradictory, I think, because it is denying that we even that we perceive things as changing and passing. So I think that Priest could well be right about the fact that time and change involve contradictions, but the particular account that he gave, I think, suffers from the same problems. And the idea is that if the Russellian account suffers from those problems, as I think they do, well then the Hegelian account suffers from them too. And my suggestion is I try to locate the problem not in the individual consistent localization of objects or times at one particular instant, but in the set theoretic foundation of calculus. A foundation that was, I think, already implicitly in play in ancient Greece, by the way, when we think that spreads in times and space are made of points and made of instants of time. And that I think is the problem. Thanks.
We have some time for questions.
Okay, that was great. 3 objections, very clear, very interesting objections. I don't want to take up the whole discussion period, so let me just address one of them and we can talk about the others in the tea room, okay? So I think there's interesting things to be said about all of the points. Let me just talk about the first one. So, I objected to the Russellian account in the sense that when the arrow point is moving, it doesn't get anywhere in an instant, okay? And you had a kind of tu Colóquio, which said that for me, you know, it occupies, it doesn't occupy the points in a spread. And that is what it is, that doesn't change. Okay, now I take that point, you're dead right. There is something very strange about accounts of dynamics which are themselves non-dynamic. We talked about this briefly yesterday, and I see that, okay? What I'm giving is just as much an account of change that's non-dynamic as Russell. So, no, I take that point too. And it may well be there are better accounts. I mean, that's what I could think of then. However, I'm quite open to the fact there may be better ways of implementing this idea. So, okay. So all of that is common ground. The only thing I disagree with is that as far as the arrow paradox goes, my account is no better than the Russellian account. I agree that they both lack a certain dynamic element, that's fine. But there seems to be at least one way in which my account is better than the Russellian account. Namely, in the Russellian account, you have to explain how progress over an interval is made up of 0 progress over each instant. Okay? Now, I think that's at least one thing that my account addresses. Because, okay, the point occupies exactly the spread that it does at any instant, that's true. But that has a non-zero measure, because it's an interval. So, it does make progress of non-zero measure at any instant. So you don't have this problem of how a non-zero measure can be composed of 0 measures, because it can, the non-zero measure can be composed of things with non-zero measures. So I think that's one advantage in my account. For all the problems of the account, I think it's not the case that the Russellian account and my account are on par. So I think my account does do something that the Russellian account doesn't do.
Thanks a lot. I think I must disagree with you. I agree. The spread, of course, is extended, unlike durationless points, and in this sense, it seems like it is better. But what I want to question is you're calling it progress. I mean, at an instant of time, the spread is what it is, and it is extended, of course, but that thing is not moving, in itself. At an instant of time, nothing is changing. In each state of affairs is independent from the other. So the locations of the object at one instant of time are what they are, and you're calling them progress. But why should we think that it is a progress? What makes you call it a progress rather than just an extension? So an arrow, for example, is not extensionless. It has an extension, but you wouldn't be tempted to call the extension of the arrow a progress. You wouldn't want to object to Zeno that, well, but look, the arrow has some extension, so why are you wondering? No, but that's not the problem, because the instant t is durationless in the Brasilian account and in your account too. The point t, and that is the point that is relevant for Zeno's argument, the durationlessness of the time t. And I don't think that you're not claiming that instants of time have a duration. You're claiming that at an instant of time there is a spread, and so I'm not sure. I could accept you calling that progress, but I suppose I would have to think about it. You might be right.
Okay, I'll just follow up once if I may, and then I'll stop. Okay. Look, I think we may be talking past each other here, because in a sense my representation is static, and there's nothing per se which represents dynamic progress. On that we agree, okay? But I wasn't claiming that as a virtue of my account over Russell's account. All I was claiming was that my account can explain how progress can be made, because progress is made at an instant. Now, why you want to call it progress? Well, that's another matter. But certainly the measure of points occupied at an instant is non-zero, okay? So you don't have to face this problem of adding zero to itself even an infinite number of times, because if you add a bunch of things with non-zero measure, you get something with non-zero measure. And that was the only advantage that I'm claiming for my account over Russell's.
Okay. So suppose now this is T0, this is T1. Now this is a progress. If Zeno is right about the arrow, that there is a problem with accretion, how does it do it if at one instant it doesn't proceed? Well, then I see exactly the same problem applying to different spreads at different times. I agree with you that the problem doesn't apply to the single instant of time, but the relevant notion of progress must be this, I think. It must be different spreads at different times, and if there is a problem with the standard account, I see exactly the same problem there, because this point here must proceed, and at an instant of time it proceeds not at all. But maybe I'm not seeing exactly what your point is.
We can talk in the two.
Yeah, of course.
So I feel I have to say some words in defense of Hegel, which is very, very rare in my life. But I'm going to do it. I completely agree with you that very often people think that from the very fact that we welcome contradiction, we have an understanding of becoming. It's not true. What is more or less clear is that when we think becoming, we feel that we are compelled to admit something of contradiction, but it's not the same. So I completely agree with your point about that. But then I think what Hegel meant
is that we already have dynamic in the operation of negation. That what he calls negativity, what the Hegelian people in the whole world call negativity means exactly that. So they think that not P is not a static counterpart of P. Not P is something which ontologically arises of P by something which is a kind of doing. P does itself not P for Hegelian. And so, but you can, I completely agree with you that this is nothing but a philosophical presupposition. Okay with that. But he offers an ontology at the basis of which we have an operation which already is doing. So we have from the very beginning sense of time. We have from the very beginning dynamic. And from the Hegelian point of view, all our static views are abstractions, because the core of every reality is that self-operation of negation as a kind of doing. So I don't know if everyone has to be Hegelian. I don't know if this way of thinking makes sense, but that's what Hegel thought.
Thanks a lot. Well, I don't know much about Hegel, but I think that if you were right, this would spoil Graham's good point, which is to distinguish stasis from motion. I mean, if any negation has this kind of a motion within it, well then what distinguishes me now from me moving? And I think that the very good thing about, this is a point that Graham has against Russell, that you can actually tell exactly what it is, the difference between me standing still and me moving. And it is that now I'm realizing contradiction, and now I'm not. But the negation is there anyway, because I am not there right now. So if the mere fact of not being there constituted some kind of motion, then you lose this capacity to distinguish static realities, mathematics, or
You're not Hegelian.
Hmm?
You're not
No, probably not. Probably not. I don't know. Should probably be.
We have some time for one more question.
If someone else has a question, let me ask it. But if not, I'll just make a comment on that.
I think you can read.
Okay, so I guess I called this thing the Hegelian account of motion. And it wasn't because I was trying to do justice to Hegel's account of negation. That's a much more complicated matter. I call it the Hegelian account because it takes off from a passage in the Logic where Hegel discusses motion. And he says exactly this, but of course in German. What is motion? Well, it's not to be here at one point of time and here at another, but at one and the same time to be here and not here, and this here both is and is not. So, never mind his account of negation. I mean, this is his claim about the nature of motion, and all I was trying to do was to invoke his name to justify the kind of account I was giving.
Thanks. But do you agree that if we thought that the whole thing is already contained in any negation, you would lose the capacity to distinguish motion from stasis, which is a very good point of your account?
Well, of course, you've got to define negation if you want to define the notion of contradiction. Now, there's a question of how exactly you understand negation, and of course, in Hegel, that's a hard question. But I think the precise understanding of negation is not relevant to the phenomenon that interests you and me here. It's interesting elsewhere. But I agree with you that, I mean, one of the virtues of my account, maybe not a big one, but there is an intrinsic difference in the state of motion, which you can't have in a Russell account. It's inconsistency, that deploys negation, whatever you want to mean by negation.
Thanks.